Today I'm going to take you through the basics of the scientific method. This is the method that scientists use to test a hypothesis or answer a question. The process starts with making observations. And there are many ways to make observations, but generally think of them as descriptions of objects, events, or experimental results. When you make observations, you use your five senses, such as touch or texture, smell, taste, sight, and sound. And you can report them written as drawings, diagrams, or in words. It's important to remember that observations do not include your opinions, such as that smells gross, or this is yucky, or it feels weird. There's two types of observations. Qualitative observations are those things that you report in words. Notice that the L in qualitative matches with the L in letters to help you remember that when you write a qualitative observation, you're writing out letters that make up words. So for these, you use your five senses. Ask yourself the question, what do you see, what do you hear, what do you taste, what does something feel like, or how does it smell? You're describing the qualities of the event or the object or the experimental result. So if you notice a color change, the liquid went from green to red, that's a qualitative observation. The other kind is quantitative observations. These are descriptions that you write using numbers. Notice the N in quantitative goes with the N in numbers to help you remember. These are measurements that you would use a measuring tool or count something in order to get. For these, you're describing the quantity of something. So you might say the temperature is 35 degrees Celsius. Related to observations are inferences. Inferences are when you take those observations and you make a conclusion based on those observations. This often provides a reason for the event or the object that's being observed. Now it's time to practice making some observations. If you look for page 3 in your binder, which is titled Qualitative and Quantitative Observations, I'd like you to read the opening paragraph on the side with the plant, and then make as many qualitative observations as you can. Keeping in mind, some students have gotten up to 15 different observations. These can just be in a bulleted list. Let's review these two types of observations again. Qualitative data deals with descriptions. Quantitative deals with numbers. Qualitative data can be observed but not really measured. Quantitative, the data can be measured. Qualitative data involves colors, textures, smells, taste, appearance, beauty, etc. Whereas quantitative data deals with length, height, area, volume, weight, speed, time, temperature, humidity, sound levels, cost, members, ages, etc. Qualitative refers to quality, whereas quantitative refers to quantity. If we look at this example of an oil painting, some qualitative observations you could make might be that this is picturing a lake scene. The colors are red, green, gray, and yellow. It shows light and shadow. Perhaps if you were seeing the actual painting, you could say it smells old and musty, or that the texture shows the brushstrokes of oil paint. Quantitatively, you could say the picture measures 10 inches by 14 inches. It weighs 8.5 pounds. The surface area of the painting is 140 square inches, and the cost of the painting might be $300. For a second example, we can look at this latte. Qualitatively, we could say it smells like coffee and cinnamon. It has a frothy appearance. The taste is bitter. The cup is made of glass and it's smooth, and it feels hot. Quantitatively, you could say there are 12 ounces of latte. The serving cup is 7 inches in height. The cost is $4.95, and the serving temperature is 150 degrees Fahrenheit. Notice the difference between qualitatively saying it feels hot and quantitatively telling you that the temperature is 150 degrees Fahrenheit. Our final example is a picture of this chemistry experiment. Qualitatively, we could say there's a green layer on top. There's an orange or yellow layer on the bottom. You see smoke, and it feels cold. Quantitatively, You could say that the chemist added 50 milliliters of liquid 1, 25 milliliters of liquid 2. The time for the change in color to appear was 3 minutes. The temperature is 30 degrees Fahrenheit, and it produced smoke for 1.25 seconds. Moving on to variables in controlled experiments. What is a variable? The goal of an experiment is to see if one change in the way something is done will affect the results you get. Variables are all the parts of an experiment that you change or make sure stay the same. There are two groups in a controlled experiment. The experimental group is the part of the experiment in which a factor, or a variable, is changed. This is where you test the factor you're curious about. You want to know if some factor, affects something else. The second group is called the control group. This group in the experiment is where everything is tested under normal conditions. There is no changed factor. That factor you're curious about is not present in the control group. And the reason you have a control group is to compare the experimental group to something so that you know if the independent variable made a difference, if the factor you're curious about actually affected the results. Moving on to two types of variables. The independent or manipulated variable is the factor in the experiment that is changed by the scientist. This is what you are testing. And good experiments test only one independent variable at a time, but that independent variable may have a few different categories, such as you could be testing temperature, and your experiment could test hot, lukewarm, and a cold temperature. The variable is temperature, but there are several categories underneath that. The dependent or responding variable is the factor that you're measuring as a result of the independent variable. So this is what actually happens in relation to the thing that you changed. The final type of variable are controlled variables, and usually there are many of these in an experiment. These are factors in an experiment that are kept the same for every category and group. That way you know when the experiment is over, if there was a difference in results between the control group and the experimental group, you know it was because of the variable you changed, not because of any other random thing. Moving on to forming a hypothesis. Before you actually test your experiment, you need to make sure you have a testable question. That testable question then leads to your hypothesis. For example, a testable question might be, what affects the cohesion of water on a penny? Your hypothesis then becomes an if-then-because statement that describes your expected results. It's important to always support your idea with a reason. And when you write your hypothesis, the if, then, and because have particular things that go with them. After the word if, you would tell your reader the independent variable you are testing. After the word then, you tell your reader the dependent variable you are testing. So it's set up to say, if we test this, then this will happen. And finally, after the word because, you state your reason why you think your if will determine the results of the then. Now it's time to practice forming hypotheses, which you will do in class. Moving on, once you've formed your hypothesis, you can write the procedure for your experiment. The procedure are the directions and materials for completing the experiment. It starts with a list of materials. You basically list out everything that you would need to do this experiment, especially if someone else were doing the experiment. So if we think about this, what items might we need for the penny experiment? After you list your materials, then you write your procedure. These are the steps followed during the experiment. It's kind of like a recipe. You write your list as a numbered list with your numbers going along the left-hand side of the page. Make sure you don't put number 2 at the end of the sentence for number 1. start a new line for number 2, and move on from there. Your steps should be detailed enough that anyone could follow exactly what you did. And it needs to include how many times you are going to repeat the experiment. It's always important to do more than one trial in your experiment to make sure your results really are the correct results. So to practice writing a procedure, I would like you to write a procedure that my friend Martian can follow in order to make a peanut butter and jelly sandwich. Start by listing your materials, A, B, C, and so on. Your numbers go down the left. You generally write one sentence for each number, and you start each sentence with a verb, like take, place, open, and so on. Once your procedure is written, you can move on to creating a data table. Data tables include all the measurements gathered while performing the experiment. They're always made before the experiment starts, and they need to be categorized so it's easy to figure out when we did this was the result we got. Let's take a moment and look at how to set up a data table.
How can I use this two-way table to figure out who has a cell phone and a MP3 player? In this lesson, you will learn how to identify bivariate categorical data by reading a two-way table. Let's review. When we have data in a table, it is often organized in rows and columns. The first row represents the column headings, while the first column give the row headings. We can look at the numbers inside the table and know that John Williams has 12 books. A common mistake when looking at two-way tables is realizing when you want to find out the total number of people that were surveyed or the total number of items that were represented, you can take the total of each row or you can take the total of each column. You can take the sum of those totals just by row, or you can take the sum of those columns. You should get the same number either way. So we can say that this table represents 34 people who were asked about 2 different categories of data. Let's look at two-way tables. A two-way table shows data that pertain to 2 different categories. Here is an example of a two-way table. This two-way table asks to see if people own a cell phone or not, and if they own an MP3 player or not. This cell represents the people who have a cell phone and an MP3 player. This cell represents the number of people that have no cell phone but they do have an MP3 player. This cell represents the number of people that have a cell phone but no MP3 player, and this cell represents the number of people who have no cell phone nor do they have an MP3 player. We can total the numbers going across. In the first row, we would end up with the total number of people who have an MP3 player, and on the second row, we would end up with the total number of people that do not have an MP3 player. We could also total the columns. The first column would be the total of people with a cell phone, while the second column would be the total of people with no cell phone. In the bottom right-hand corner will be the total number of people sampled. This total is the sum of the 2 row totals, or it's the sum of the 2 column totals. Both of those sums should be the same, so it doesn't matter which way you calculate that sum. Let's look at a two-way table with some real numbers in it. This two-way table tells me that there are 27 people with a cell phone and a MP3 player. There are 6 people with no cell phone but have an MP3 player. There are 13 people with a cell phone with no MP3 player, and there are 4 people with no cell phone and no MP3 player. We can total the rows to get 33 people with an MP3 player altogether, and a total of 17 people altogether do not have a MP3 player. We can also total the columns. We have 27 plus 13 or 40 people with a cell phone, while we have 6 plus 4 or 10 people without a cell phone. And the grand total is going to be the sum of the row totals, which would be 33 plus 17, which gives you 50. Or you can sum the column totals to get 40 plus 10, which is also 50. In this lesson, you have learned how to identify bivariate categorical data by reading a two-way table.
So hopefully that makes things a little more clear as to how to read a two-way table, or what we call a data table. You have to match up the column and the row, kind of like a multiplication table, and look at what is in the box that connects to both the column header and the row header. So to make a two-way or a data table for this particular experiment, we're going to follow this example. Your row headers, remember rows go side to side. The header for the row is found on the left. Your row headers are going to be trial 1, trial 2, trial 3, and average. Trials are the time or the number of times you repeat the experiment. Your column headers, columns go up and down, so the header is found at the top. Column headers are going to be your control category and the units you're reporting that in, your independent variable category 1, and possibly your independent variable category 2. These actual titles will be different for everybody in the class because you each get to choose what independent variable you want to test. And finally, the results from your experiment will be written in these boxes. So for trial 1, the first time you test it, the first time you test your control category, you will record your information in this box. The first time you test your first independent variable, you will record the information in this box, and so on. When you are finished collecting your data, it's time to graph that data. A graph is a good way to visually analyze your data, and it includes a bunch of things. Here's the list of things that need to be included in your graph. You need an x and y axis. The independent variable that you tested goes on the x-axis. The dependent variable goes on the y-axis. You need an interval. This is a term that you need to know for both math and science. Interval means what you count by. So you determine your interval based on the data that you actually got. If your numbers are really high, you count by a higher interval. If your numbers are relatively small, you count by a lower interval. It's important to remember to count by the smallest interval possible while still being able to fit all your data on the graph paper. So, just for an example, if you had data that only went up to 10, you might count by ones. Each line would be worth 1, so you would count 1, 2, 3, 4, 5, and so on. If your data went up to 20, you might want to count by 2s, 2, 4, 6, 8, 10, and so on. Also in your graph, you need a key. Your key will show one color for each bar. For example, all trial 1s will be the same color. And then graph your actual data. Trial 1, trial 2, trial 3, and the average for each category that you tested, including the control. And finally, usually at the top, find a place to write a title for your graph that describes what your graph is showing. Here's an example. Let's say we tested the effect of water temperature on the number of drops. Once we've put our x and y axis on the paper, we need to make sure that we have labels. Our dependent variable was number of drops. Our independent variable was the temperature of the water. Notice I have both the overall independent variable and I have the separate categories. We tested room temperature water, cold water, and hot water. Then, based on the data we got, we determine the interval. In order to fit the data on this particular graph, it's required that we count by 2's for each line. So you can see the first line is mark 0, which it should always be mark 0, and then 2, 4, 6, 8, and so on. Since our largest piece of data was 66, we need to go a little bit beyond that. Next is the key. The key shows us that this turquoise color shows trial 1, blue is trial 2, white is trial 3, and the black bars show the average for each category. Make sure you're graphing one bar for each trial and group them by category. Notice all of these are stuck together and then you have a space. All the cold water information is stuck together and then you have a space. Up at the top we have our title. Moving on to the final step in completing a scientific experiment, this is to write a power conclusion. Once you've done the experiment, analyzed your results, graphed your results, it's important to write a paragraph or several paragraphs in conclusion telling the person reading your report exactly what you found and what that means. Here you analyze that data to determine the final outcome of your experiment. You think of things like what do you now believe as a result of the experiment or the observations. You make sure that you restate your hypothesis or at least relate your findings to it. You support your claim with at least 2 pieces of data, and you use a good explanatory language. This is also a spot where you discuss what went wrong in your experiment or how you could improve the experiment. And finally, you publish your findings so that other people may benefit from your work. So these are the parts of the scientific method, which we will be going through step by step in class throughout this first unit.